All right, 9.3, we're talking about geometric sequences. When the ratio of two consecutive terms is a sequence is constant, so now we're looking at the ratio, then the sequence is a geometric sequence. For example, the sequence 2, 4, 8, 16. So notice if I look at the ratio 4 over 2, I have 2. If I look at 8 over 4, 2. So we can see that it's a constant rate. And multiplying by 2, in other words, is a geometric because that ratio of consecutive terms is 2. We call the first term a sub 1, and the common ratio consecutive terms r. Then the terms have this reoccurrence series. A sub 1 times r, a sub 1 times r squared, etc., etc. So now, determine whether the given sequence is an arithmetic, geometric, or neither. So try to see if you can figure this out. So hopefully you see that the first one has a common difference. Remember that constant rate of change is going to be 3. So that's going to give us an arithmetic, just like the last video. Number 2 has neither a common difference nor does it have a common ratio, especially because we're looking at that n squared in that exponential space. So that's going to be neither geometric nor is it going to be arithmetic. It's going to be a totally different sequence. And then the last one, we see that it does have a common ratio and it's going to be 3 over 2. So if I think of the term, the first one would be 3 over 2, right? The second term would then be 9 over 4. That third term would then be 37 over 8, etc. So then we can kind of start seeing the common ratio. So if you take the 9 over 4 and divide it over the 3 over 2, we see that their common ratio is going to be 3/2. So that one is in fact going to be geometric. The nth term of a geometric sequence can be given to us in this form. So just like the nth term of the arithmetic sequence, right, we want to note that the ratio cannot be equal to 0, right, or else we just end up with 0 all the way around. So let's find the terms for all of these. So for A, we're going to find the formula of the nth term, and then for B, we're going to use the formula to find the fifth term. So let's start off with our generalization. So we have A of n is equal to our initial value, which is 7, times our ratio, which is 5, and then that's going to be raised to the n minus 1. Okay, so now we want to, so that was part A. Part B is now find the fifth term. So here's 7 times 5 to the 5 minus 1, which is going to be to the 4th power. And so this gives us 4,375 is going to be the fifth term. Try the second and the third one. All right, so for number 2, hopefully you obtain that the fifth term is going to be 7 over 81, and that our general form is just a sub n is equal to 7 times our ratio, which is 1/3, raised to the n minus 1. For number 3, our general term is a sub n is equal to 3 times negative 5 raised to the n minus 1 power. So our fifth term ends up being 1,875. Let's take a look on the next page. We want to find the 10th term of the geometric series. So we want to kind of keep in mind the equation of a geometric series, which is that we have the a of n is equal to a1 times r to the n minus 1. So if we're finding the 10th term, we need to find out, well, we know our initial value is going to be a1. It's going to be 1/3. So what is our ratio? So 1/3 to 1, notice I'm multiplying by 3. 1 to 3, I'm multiplying by 3. Okay, so we can see that the ratio here is going to be 3. So I have, for instance, 3 over 1, and it's going to be 3. And then I have 1 over 1/3, which is also 3. Okay, so our ratio is going to be 3. So this tells me that the nth term can be given as 1/3 times 3 to the n minus 1. So that means our 10th term will be 1/3 times 3 to the 9th power. which is equivalent to 6,561. All right, let's look at the next one. For the geometric series, we want to find a sub n. So here we're just finding the general form. So notice this ratio. So we're going to have 1 over 2 is the ratio for the first one. And then we're going to have 1/2 over 1, which is also 1 over 2. So we can see that we're basically going times a half, times a half, times a half. So our ratio here, so our a sub n is 2, but our ratio is 1/2. So our equation is going to tell us we're going to have a sub n is going to be 2 times 1/2 to the n minus 1 power. All right, let's look at the sum of the first n terms. So looking at a geometric sequence, the sum of the first n terms is given to us by this formula. Notice that r cannot be 0. It also cannot be 1. Okay, so that's important to note. So let's take and see if we could figure this out. So we want to find the sum. If necessary, express your answer in many decimals as your calculator allows. So the first one is going to be a generalization since we don't know what the last term is. So the first two are going to be generalizations, and then we'll see some actual calculations towards the end for 3, 4, 5. So for the first one, we're going to have S of n is equal to our original term. Or here, let's just write out the formula first. 1 minus r to the n over 1 minus r. So what is happening here, right? So notice that the first term is 1/7, so we know a1 is going to be to 1/7. But now, what's the ratio between 3/7 and 1/7? So 3/7 over 1/7. This is the same thing as saying 3/7 divided by 1/7. Which is the same thing as saying 3/7 times 7 over 1. So our 7's go away and I end up with 3. You can also look at it as our outer over inner. So 3 times 7 over 7. But those 7's cancel out, so we end up with just 3. And then if we look at the next one, we still have the 1/7 there, but what's the difference? The difference is that 3 is now growing to a 3 squared. Okay. So if I look at 3 squared, 3 over 7, 3 squared over 7 over 3 over 7, and we kind of go through the same process, right? My outer will say, well, I'm going to have 3 squared times 7 over 3 times 7. Well, my 7's gone. And then my squares would reduce, so I'd end up with 3 again. So I do see that the ratio, that change that is happening here, is I'm multiplying by 3, multiplying by 3, multiplying by 3. So that ratio is going to be 3. All right, so hopefully that was clear in terms of why we got that ratio to be 3. All right. So now let's look at the sum. So the sum of n is going to be 1 over 7. And then in our numerator, we're going to have 1 minus 3 to the n all over 1 minus 3. 1 minus 3, that's going to give us a negative 2. So this turns into 1/7. 1 minus 3 to the n over 2, negative 2. So we end up with 1 over 14 times that by 1 minus 3 to the n. But this is a negative. You could also play with the signs here and end up with 1 over 14 equals 3n minus 1. If you wanted to get rid of that negative, let's make sure it's clear that there is a negative here. Okay. Either way is fine. All right, let's look at, for number 2, go ahead and try it out. It is going to be a general, and then we'll do number 3 together, and then I'll have you try 4 and 5 on your own. Alright, hopefully for that sum you ended up with 5 over negative 6 times 1 minus 7 to the kth power. And you can see the work there. Alright, let's look at number 3 together. So number 3, we want to find out what is the ratio and our initial value. So our first value is going to be 8. Our ratio, we're going from 8 to 24. So if we take 24 over 8, that's 3. If we take 72 over 24, that's also 3. So we can see that our rate is going to be 3. So let's go ahead and find the sum. So we notice that we can see here also, here's our initial, and look, it's already written in rate format, where 11 is the last term. So we have 11 there. So the sum here, and this is going to be because we're at 11, and if we come back up here looking at our sum term, sorry, not our sum term, our equation, right, our a sub n, it's going to be n to the minus 1. So this is telling us that because this is 3 to the 11th, this is going to be the 12th term. So it's going to be the sum of the first 12 values. So if it's the sum of the first 12 values, we are going to have, here we're going to have 8 times 1 minus our rate to the 12th power all over, here, let me write this down, it's not so squished, 1 minus r to the 12th power all over 1 minus r. So 8, we're going to have 1 minus 3 to the 12th power all over 1 minus 3. So 1 minus 3 is going to give us a negative 2, and then 1 minus 3 to the 12th power is going to give us a large number, and then we're going to multiply that by 8. So when we do this math, this is going to end up being a really large number. We're going to get 2,125,760. Uh-oh. That was weird. 760 as the sum of those 12 numbers. Okay. Alright, try number 4 and number 5. We are, for both of these, we're just looking at the fifth term. So we're just going to plug it in to find out what that fifth term is. So find your A1. Find your, actually we don't need A1, we just need our R's. We need our initial value, and we need our rate. Our first term and our rate. Take a moment to try that one. Alright, so for number 4, hopefully you got 1023. Notice we are taking that 4, that rate of 4, and we're raising it to the 5th power. Now, the difference with the number 5 is that even though we're finding the 5th term and the initial value is larger, because we have that negative, that ends up changing a little bit of the game. So we end up with a total of 820. And that's it for this section.